everyone, so today we're going to be learning about 4.6, which is about watersheds. And the learning objective for today is that you can describe the characteristics of a watershed. We're going to be learning the basics of watersheds and some of the different attributes and characteristics that determine this watershed and its characteristics. Let's first start out with some basics of what is a watershed. A watershed is going to be an area of land that drains all of the streams and rainfall into a common outlet, such as like a lake or the ocean. And the water is going to be flowing from areas of high to low altitude, just because that's how gravity works. Now there's this thing called the watershed divide, and it's sometimes also called the drainage divide. And these are going to be the hills and ridges that form the boundary of the watershed. So if you look at this diagram here, we've got like a mountain area, and in the middle is going to be the drainage divide between these two watersheds. So this first watershed is going to be on the left-hand side of that tall ridge, and this watershed is going to be on the right-hand side. So the part that divides between the two of those is going to be called this watershed divide. Now, actually, all watersheds are mapped out. This is something that we have already done over time. So if there were to be a raindrop that fell anywhere in the state of Washington, we know what watershed it belongs to, and we ultimately know where it will go once it falls through, gets into a stream, goes through the river, and gets to its final destination. And here in Washington, we have about 60 different watersheds. You can see how they're mapped out. They're kind of jagged lines because this is where we're going to be following higher altitudes or mountain ranges or hills or things like that. But ultimately, these are going to vary in the size and the shape, and these are going to be based on certain different characteristics of the area that form different shaped watersheds. So let's go into the parts of a watershed. We're going to have tributaries, and these are going to be streams or creeks that feed into a main river. So if you look on this diagram here, it's all these smaller little creeks and streams that are ultimately flowing down into this main river. So main river is going to be the second part of a watershed. It's going to be kind of the main flow. It's larger compared to these streams and creeks, and ultimately the streams and creeks are going to be going down from high altitude to low altitude to get into this main river. Now, this main river is eventually going to empty into a main body of water, like a lake or ocean that you see down here. But throughout this river, there's going to be areas called floodplains, and these are going to be areas that flood when the river gets really full. And they tend to be lower elevations in the watershed. So you aren't going to find like a floodplain up on top of the mountain. It's going to be here in the valley area, so that if we get a bunch of rain and it floods, it's going to be those flat areas where it pools out into and creates a floodplain. Now, in addition to all the rivers and streams and getting to a main body of water, another part of a watershed is actually going to be the groundwater. And that's the water that soaks into the ground all throughout the watershed. So if we look at this, the little white dots are going to be the boundaries of this watershed. Any water that soaks into the ground is going to be considered part of this watershed, and ultimately it's the groundwater. And even through this groundwater down here, there's large underground reservoirs of groundwater, and those are called aquifers. And so all of these parts together are going to be making up the whole watershed of this specific place. So there's different characteristics that are going to determine a watershed and some of the various aspects of the runoff in that watershed. So the first one is going to be the area and the length. So this is going to affect the volume of water, like how much water is actually going to be flowing in this watershed is determined by how big it is, how long it is. As you saw on the map of Washington, they can come in different sizes. And so that's going to be a characteristic that can be different between other different watersheds. The other thing is going to be the slope. This is going to affect the momentum of runoff. You could have a watershed that's happening like in the Cascade Mountain ranges where it's coming down steep mountains, or you could have it in eastern Washington where Technically, it's a little hill, so it's going from high to low, but that's going to be a very different slope, and the momentum of the runoff is going to be very different than if we were talking about water that's running off of Mount Rainier. Another thing that's going to be a characteristic of a watershed is the soil. So typically we are going to have pretty fertile soil in the floodplains where you get a bunch of the sedimentation that floods out. And so floodplains are actually going to be areas where we tend to see a lot of farming occur. Additionally, in a watershed, we are going to have vegetation, and this is going to determine the amount of runoff, and it's also going to impact soil erosion because vegetation is the roots are going to take in water, and it's also going to stabilize the sides of the river or the creeks, and so it's going to determine if this is an area where you're getting a bunch of soil erosion or if the vegetation is kind of holding it in and the water's not going to have as much sedimentation in it. Additionally, vegetation is important because plants filter water. So that's going to kind of determine the cleanliness of the water that ends up eventually at the final destination. So these diagrams are just going to be kind of visualizing somewhat of what I just talked about. So the first picture is showing slope. Both of these are going to count as watersheds, and the one on the right has a much higher slope, which means the water is going to be moving down faster. The one on the left, it has a different type of slope. And so you're going to have kind of wider floodplains. You're going to have probably slower moving water. And additionally, the areas of both of these could be different. So the one on the left has a larger area than the one on the right. And all of these are going to be impacting the volume of water that's going to be ending up at this final main body at the end. And this diagram on the bottom is actually from a study that was showing what are going to be some of the main factors that influence runoff and soil erosion. Now, the first part was going to be precipitation. The more it rains, the more runoff you're going to get. But the second part was actually vegetation. And they tested a variety of different trees and grasslands and types of trees, and they determined that it ended up having a very large impact on the amount of runoff that was coming off of these areas where the trees were growing. So these are, as I said, going to be very important for determining some of the amount of runoff in addition to the soil erosion. And the reason why this is all really important is because all of these characteristics need to be identified for management and for planning. So if you think of different parks departments that are trying to determine how to best take care of a certain watershed area, or you can think of city planners when they're trying to determine where certain things should be developed, they need to take the watershed into effect. You need to know if it's a floodplain and it's very common for this area to get flooded, or if the trees that you're potentially going and chopping down are going to have a large impact on the quality of the watershed. So all of these things are important for those who are trying to manage and plan around watersheds. Now, humans are going to be able to impact watersheds in quite a variety of ways. And some of the ways that humans impact watersheds are going to be through logging, which is going to remove vegetation, development, for example, non-porous material. So think of cement, think of buildings. That's going to prevent groundwater from infiltrating and seeping into the ground. And additionally, it's going to increase pollution runoff. So if you are having areas where you used to have a forest and now you have a parking lot with cars that are spilling oil and it's getting washed off and that oil is going straight into streams nearby, humans are going to be having an impact on that pollution that's getting into the ground or that's getting into the watershed. And additionally, development can impact sedimentation too. Think of an area where you're having a bunch of construction. You're going to be kicking up a bunch of dirt, dust. You are going to be removing trees, and that's going to impact some of the soil that's potentially running off into this watershed. Additionally, dams have the ability to change the flow and the floodplain of watersheds. And there's quite a few different ways that pollution can enter the watershed. And the first one, as I just mentioned, is going to be urban areas where you can have spills, you can have stormwater runoff, you can just have general waste from people leaving trash on the ground. And all of these, ultimately, when you have precipitation come in and push it off, this is going to end up in the watershed eventually. Additionally, agriculture is going to be one that can really pollute the watershed from things like using heavy amounts of fertilizer, and that can run off, or animal waste. Think of a whole area of cows and the potential waste that can be introduced to the watershed that would not have been there before humans came around. Now, the reason why pollution is a big deal is because all this pollution gets concentrated in the main body of water. So if you look at this diagram up on top, it's showing a wide variety of ways that pollution can enter, or even that humans can impact. For example, you could have a house with a failed septic system, and all of a sudden the waste from their septic is ending up in the groundwater. You can have development right next to lakes and rivers, and that's going to be causing things like runoff where toxins can get in. Deforestation, even up in the mountains, is going to make it so that you're having more soil erosion and sedimentation is getting into that watershed and flowing down. You can have road construction, agriculture, kind of all of those things. And if you look at all these tributaries and rivers, they all ultimately are going to end up here in the ocean at the very end of this. And so even if you only have a little bit of pollution here, a little bit here, a little bit here, it's all going to get concentrated, and you're going to end up with a lot of it in this main body of water, which is obviously a huge problem for anything that lives in this water, or even if humans need that water, like if it's a lake that humans are often using. And this diagram here is going to be just a picture of what I said with the dams. If you look at where that river might have originally been, a dam's going to come in, it's going to trap all the water, and it's going to affect what originally might have been a floodplain and the just overall size of this river as it's moving throughout the watershed. Sorry, guys. Sorry, my transitions were apparently clearly off. Anyway, so this is going to be your practice FRQ for 4.6. So I want you to look at this diagram here. It's just kind of showing you some different things that could be in a watershed. We've got rain, we've got streams, rivers, we've got some human impacts as well. We've got like farm, city, houses, dam. So what I want you to do is I want you from this image to identify one impact that humans could have on this watershed. And I want you to explain how this impact could affect the watershed. So that's going to be your FRQ for 4.6. And these were your notes on 4.6, which was about watersheds.